Last example we're going to do for the addition method. Here we have two equations where it's a little bit easier to get one equation to multiply up to the other, at least the coefficients here. You can see the 4 multiplies easily to the 12, the 1 multiplies easily to the 3, and so it doesn't really matter which one we choose. I'm going to go ahead and try to eliminate the x's here so that we can get 12s on both of these coefficients. So I'm going to start out by multiplying this bottom row by a 3, right? I need 3 times 4 to give me 12, but I also need to get an opposite sign here. I need one to be positive, one to be negative, so I'm going to use a negative 3 to give me the opposite sign. So when I do that, this equation is going to become negative 3 times 4, which is negative 12x. Negative 3 times negative 1 is positive 3y. And negative 3 times 7 is negative 21. Now the top equation stays the same. It's 12x. I'll just bring it over. Minus 3y equals 21. And when I add these up, the x's add up to 0, the y's add up to 0, and the other side of the constants add up to 0. Interesting. On the left, 0x and 0y makes 0. And so I end up with just 0 equals 0. Okay? A little bit strange. But if you'll recall from the last section, we talked about true and false equations. If you get to a point where there are no more variables, like we have no more variables here, you then look at the values in the equation. If they actually are equal, I mean 0 does equal itself, then this is what we call a true equation. And a true equation, it's always true, means that these two original equations are always intersecting. And if they're always intersecting, we must have two copies of the same line. So a true equation here means that you have two copies, I'll write it over here, two copies of the same line. Okay? It also means that there are infinitely many solutions. Infinitely many solutions. Okay, so it's essentially two overlapping lines. Alright, we did this before. You get a line going up, you get the other line right on top of it. So you really can't even see the difference there. Okay, so here's how we're going to write out the solution. Remember, we want the x-y combinations, all the intersection points. And we did this before, but I'll show you this again. We have to have x, and we have to have some expression for y. The y value is going to be found, or the y expression is going to be found by solving one of these for y. And it doesn't matter which one, they'll give me the same thing because I have the same line. So I might as well use the bottom one because the y is easier to solve for. So we'll take that off to the side. Let me grab another color. We'll do 4x minus y equals 7. I'm going to subtract the 4x from both sides. So those drop out. I get negative y equals negative 4x plus 7. Again, these are unlike terms, so I cannot combine them. And then I'm going to divide by negative 1 to free up the y. And that changes all my signs. So this becomes y. this becomes positive 4x, and this becomes a minus 7. So our final solution then is going to be all points of the form x comma 4x minus 7. And as long as your points satisfy that condition, it will be a solution to the system. Okay, so that pretty much does it for addition method and for everything on this first week of online instruction. I hope you guys enjoy your weekend. Be looking for a test coming up shortly on e-learning, and don't forget to like and subscribe, as they say. Thank you very much.